Yeah, recording started, I think. Yeah. So in last class we stopped basically in this on this slide. Okay. Can you hear me clearly?
Yes, sir. Yes.
Yes, sir.
So we talk about the density. Okay. So in the last class we talk about the density, and then and we said ki density is what I said ki in physics also we compute the density equal to mass per unit volume. So in case of in our data mining or machine learning area, we use the density almost the same way. But here, as I said, the points is nothing but an objects. Okay. So in physics also that is the object. So here also that it is a representation of an object. So therefore, per unit volume, how many objects are there? So that gives the basically the density. That is, we stop at this point, and with a commitment that we will be exploring more in details while talking about clustering and outlier detection. Okay. So as I said, this is the first or series of class where we just touch upon the different topics of data mining, and we will be exploring later those topic in details. Okay. And since some of the topics basically overlap with machine learning, so I will not cover them. Okay. So data pre-processing. Okay. So we'll be talking about aggregation, sampling, dimensionality reduction, and more mathematical things you will see in later phase or machine learning course. So I should wait until that machine learning course complete that part. Okay. So otherwise at the end I may cover this something in dimensionality reduction and feature subset selection, features creation and discretization and binarization, and finally we'll talk about the attribute transformation. Okay. So this is all part of data pre-processing. So pre-processing is a thing, as the name suggests, that before doing anything, that is our main objective. So we should use this process. That means if our objective to analyze a particular data, before start analyzing, we should use these techniques. Okay. And as I said, hello, any issue?
No,
No,
sir.
sir.
I am getting echo. No, okay. So next we start talking about aggregation. Aggregation is simply combining two or more attributes into a single attributes. Okay. So purpose of aggregation is data reduction. Okay. So one example is like we may have the date of birth along with that age. As you understand, it is not necessary. One of the things are necessary. So one we can omit. So that is irrelevant feature. We can omit it, and sometime also reduce the number of attributes of that is the purpose. And cities aggregated into region, state, countries, etc. Okay, that is a different issue. What I example that will come later. But here is aggregation means you are combining the two attributes and represent it a single one. So suppose as one simple example, that is region, state and countries. Okay, so region, state and countries can be combined. So let's say uh, uh, when we talk about the city of Raurkela, but when you talk about the that city and then 2-3 cities in a state can be combined, and we can get the total value of the particular state. So this is one example of the combining two or more attributes. So another example, days aggregated into weeks and months or year. And when you aggregate the data, so that will have the less variability. Okay. So some cases we may not need to have very fine details about some particular region or particular attributes. So that might lead to different issue. Let's say your CGPA. Okay, so in some of the subjects you got excellent, some of the subject you got C, and some of the subject is B. So when you talk about your performance, so we generally talk about the CGPA. So CGPA is like a combining the results of two or more attributes. Okay, so that is the purpose of when analyzing the student performance, instead of analyzing the each subject. So over 4 years you will be studying 25 papers in theory papers. So it will be very difficult to analyze your performance. Instead of, if you go through the what is the CGPA over the year, then we can say uh, how your performance decreased, degraded or improved. Okay, so that is the purpose for aggregation. Okay, so this is one example that how much rainfall happen over a time in Australia. Okay, so that, as I said just few minutes before, that aggregation data tends to have the less variability. Okay, so you can see one example here. Uh, if you see on the left side, you can see that variability of data is much higher than on the data on the right side. I think uh, you can see the slide, but unfortunately the slide number is not visible. Tell you the slide number, but uh, I can tell you the title, so you can match. That is example in precipitation in Australia. So that is the, and then we have the diagram. That is, we are talking about that on the right hand diagram, that is the plot or histogram. On the right hand side is having less variability with compared to the left one. So that is our point. So when you have aggregation, your variability in the data will change. Okay, so another way, say one example is, let's say if I say what is the min CGPA, it does not make sense. But what is the mode of your student CGPA in a class? So even though that makes sense, so that is confined. Say 100 student will be confined only a single results. Okay, so that also does not give a huge impact. So therefore, whenever you aggregate the things, so we need to choose how many attributes we will combine, and then what is the purpose of the analysis and so on. So as I said, that there is no single answer for any problem. So everything, analysis and other thing will depends on the specific problem. Okay. So next, talking about the sampling. So you might have started earlier. Okay, but I don't think that every student must have started this thing. Therefore, I will go through, and sometime it is good to have the review, whatever, recollect the whatever you studied earlier. So therefore, sampling is the main technique employed for data reduction. Okay, so there are two things in data reduction, and then as I said that each object is represented by a set of attributes. Okay, and then in a data set we will have a number of instances or number of objects. Okay, so therefore we have the two things. One is number of attribute of an object. Another is the number of objects in a data set. Two are different things. Okay. So you need to understand which one we are talking about. So sampling basically talks about number of reduction of data instances. So suppose you have a data where you have, say, 100 instances and 100 objects. So whenever we are talking about sampling, we are talking about reducing the number of instances from 100 to some number. So that is something called sampling. So other things are there also, that is reducing the number of attributes. So that is formally known as the dimensionality reduction. But in this slide, on this slide, we are talking about the sampling, which basically speaks about the reduction of number of instances in a data. You may question that why do you need for reducing the sample, what is the need of sampling, or why do you need for reduction of the data? If we have more and more data, obviously you'll have more fine analysis about the population or about the data, or in particular applications. You are very much right, but on the other hand, say suppose if you want to analyze the what is the characteristics or what is the other features of the population of India, and then we have more than 1 billion population. So in that case, if you start analyzing the these complex data, then it will take a huge time. Okay, so and it will take the huge time. But if you want to get, suppose government wants to launch a scheme. So before launching the scheme, so government wish to want to know that how many people will be benefited out of this. Okay, so therefore what we need to do, this is one example. Example might not be exactly correct, but it is very close to the purpose of the sampling. What is done is you take few sample out of the 1 billion population. So you take, let's say you take 50,000 people's population and you draw your conclusion. So in that case, what will happen? The objective of sampling is that it should be very close to the actual number of data instances. Whatever analysis will perform over the sampling, that will be our objective. It should be very close to if we perform the analysis over the entire population or entire data set. So that is the objective of the sampling. As you understand, so what we have the 1 billion population. So simply if I take only the data for the 100 people, it is not going to work over the 1 billion population. So therefore, sampling size also plays a big role. So what should be the suitable sample size so that the characteristics of the sampling side will be very close to the original population or original data set. So I think I convey the message. What is the main purpose of the sampling? So sampling is the main technique employed for data reduction. As I said, what is the difference between data reduction and then dimensionality reduction? So it is two different things. As I said, probably you understood. It is often used for both the preliminary investigation of the data and the final data analysis. As I said, that if you want to get the preliminary investigation, preliminary results, so very often we use the sampling technique. So statisticians often sample because obtaining the entire set of data of interest is too expensive or too time consuming. Whatever I convey is exactly the same thing. On other way around, whatever it is written, I told that. So sampling is typically used in data mining because processing the entire set of data of interest is too expensive or time consuming. It is exactly the same thing what the statistician do. The data mining people also, they do the in the same purpose for the sampling. Okay, so there are different type of sampling. The key principle of the effective sampling is the following. So using a sample will work almost as well as the using the entire data set if the sample size is representative. Okay, so a sample is representative if it has approximately the same properties as the original set of data. So we pick the representatives, say, let's say in the parliament, we used to send the MPs from the different region. Okay, and you will be aware that this representative is mostly based on the population. So if the dense region, densely populated region will have the more representative. As you see that state of UP will has the maximum or representative in the parliament because of the huge population, huge density population in that state. So therefore, we should have a proper representative to to tell that these are the representative of the entire 1 billion population. So that is it is the same thing here also. A sample is representative, it has approximately the same properties as the original set of data. So one example on the slide is a sample size is on the left side. As you can see, there are 8,000 points. So now if you reduce the number of points to 2000 points, still you can figure out what is the structure of the original data points. But if you reduce to further to 500 from 8,000 points, so it is really hard to recognize the structure of the data. So similarly, if you work with a very small size of the data, so it will not reflect the characteristics of the original population. I think you can, everything is going fine because I cannot see you just in front of me only the slides. Okay, so because I am using tab, I generally use the laptop. Okay, so therefore, if to me it looks is very odd today. So there are types of sample. So one is simple random sampling. Okay. So there is an equal probability of selecting any particular item, sampling without replacement. So in sampling, random sampling, we have two techniques. One is something called sampling without replacement, another is with replacement. Idea is very simple. For sampling without replacement, say you pick, say suppose you have the 100 objects or 100 instances in a data. So you pick any one of the sample out of 100 instances, and what you consider it when you pick it, it is in real sense you pick it. That means the same data will not be there in the same instances will not be there in the original data set. Okay, so therefore when you pick one sample from the out of the 100 instances, so then number of sample in the original data set will reduce to 99. Okay, so you picked another sample randomly out of this 99 sample. So again you pick some other sample and then it will reduce the sample size, will original size of the data will be reducing. So that is the idea for the sampling without replacement. Now what is there in sampling with replacement? So when you pick one item, when you pick one instances from the entire data, and you assume that same data is available in the original data set. Okay, in other way around, you pick one sample from the entire population. So let's say you picked one sample, okay, and then you are going to pick second one. So whenever you pick the second one, so in that case sampling with replacement, so there will be 100 sample. In other cases, you assume that sample is taken away, but in second case, that is the sampling with replacement, you consider the sample is taken away, but same sample is there in the population. So that is something called is the sampling with replacement. So as we can read out here, objects are not removed from the population as they are selected for the sample. In sampling with replacement, the sample object can be picked up more than once. As I said, because we are not taken objects remain in the original sample, and originally sample size will remain 100. It is not going to reduce anymore. So therefore what may happen, whenever we pick the one sample, in the next time there is a chance that you can pick the second sample. So therefore that is the line it is saying ki same object can be picked twice in the in case of the sampling with replacement. Okay, is it okay?
Sir.
Yes, sir.
Yes, sir.
Okay, so next
Yes,
is
sir.
stratified sampling. In case of stratified sampling, it is the idea is almost the same thing earlier, but what is the added advantage here? Added advantage is that Initially, we divide the data into a number of split. Suppose you have, suppose you have 100. Suppose you have the 100 samples. 100 sample. What you do it? You partition the 100 sample into 10 bins, and you apply the sampling with replacement on each of the bin, or you apply sampling with replacement in each of the bin. So therefore, this is something called the stratified sampling. So split the data into several partitions, then draw the random sample from the each partition. As you understand that random sampling, there are two types. So obviously you can have the so you can have the two sampling. Okay. So what is the advantage is that, say, because everything is random, in earlier in both the cases random sampling, it may happen that in a particular region, you may not get a single representative. So therefore you won't get the right analysis from the sampling from the picked samples. Okay. So therefore, if you partition entirely, say 10 partition, and then you do for the sampling, you decide, say you will pick only the 10 sample or 20 sample, and from each you pick two. From each bin you pick two. So therefore, at least there will be two representative from the each region. So that is the idea for the stratified sampling. As you understand, stratified sampling will be working much better than the only sampling techniques. Okay, so one example we can give you. Let's say we have 540 MPs in Lok Sabha, right? So now what is, say, suppose government has decided to send say 20 MPs to in some international affairs. So in that case, what you need to do it? So they should pick only 20 representative, ideally to represent the entire 540 MPs. So in that case, what can be done is entire India can be divided into a region, and then out of that one can use for the sampling technique, or one can use, obviously it should be what is called sampling with replacement technique, and then it will represent the entire India. So that is the idea for the stratified sampling. So this is one. What should be the sample size? What sample size is necessary to get at least one object from each of the 10 equal size groups? So it is shown here. Suppose you have the 10 bins, and then you want to pick at least one bin from the so this figure I will explain. I need to see in more details. I will explain later. So now we talk about the dimensional. Say in earlier sampling, we talked about basically reduction of the data. So reduction of data, as I said, it is like reduction of the instances. Okay. So now we'll talk about the reduction of the features or reduction of the attributes. Now, before going into why do you need for reducing the dimensionality? Okay. So that is something called the curse of dimensionality. So when dimensionality increases, that is the number of attributes of an object increases, data become increasingly sparser in the space that it occupies. Okay, what does it mean? I should use, I think I need to use the pen. Okay, let me first explain and then I will use. So definition of density and the distance between the points which are critical for clustering and outlier detection become less meaningful. What does it mean? So basically it is saying that when dimensionality of an object increases, okay, so suppose U can be represented using 3 to 4 features, or a student can be represented using 4 to 5 features. But if I say कि student can be represented or an object can be represented with 1000 features, so then what happened that, as I said, कि this 1000 featured, as I said, that each object can be represented as a point in a feature space. So now you imagine a feature space which has 1000 dimension, and each object will be represented as a point. So then what will happen, because you have the many dimension, so therefore distance from one object to the one object to another object will be almost similar to each other. So therefore the concept of density, as I said, density says ki number of object within a periphery of radius, say t, say how many objects are there. So now if the each points will be equidistant in a feature space, then it will be very difficult to identify which point is outlier and how many clusters and other things. So therefore what is the objective? We have to reduce the dimensionality. Okay, so that is the objective for reduction of the dimension. Okay, then a different way we can reduce the dimension, but I will show you first what does it mean, why the if the features increases, then and then why the data will be sparse from each other. So technique used for dimensionality reduction is the PCA, singular value decomposition, and many other things. Unfortunately, I will not cover any one of them. And I think in machine learning classes, you must have learned or you will be learning that is PCA. And up to some extent, you will learn also singular value decomposition uh, there is a paper taken by Pankaj sir. I think he is teaching this time. He'll be talking about the singular value decomposition and other issues. Okay, so therefore, just I will touch upon this technique, and obviously this technique I will tell. I think some other slide, that is the first point, that data become increasingly sparse in the space that it occupies. That I'll talk. This discussion is delayed little bit, and hopefully I'll get a suitable slide where I'll discuss that part. Whenever features increases, that points will be away from one point to another points. First is PCA, that is the principal component analysis. Okay, so here idea is that wherever the variability of data are there, you should take that direction and you project the points on that plane. So that is something called the PCA. I think this is sufficient for you for this class. If you need more information, maybe I need to take the another class. Otherwise, same thing will be taught in machine learning class. I think I have some slide here. Yeah, I think I should take one example and tell it. Can you see my slide screen? I don't think you can see. Can you see?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
But I am writing something. Can you see that?
Yes,
No,
sir.
no, sir.
Okay, you do. You just wait.
No.
Then. Now, can you see? Just I am writing something.
Yes, sir.
Yeah. Let's say you have a set of points. Okay. Let's say you have a points 10. Okay. 10 to, and then you have 23. You have 34. You have 45. Okay. This is 5. Okay. Okay. So now let's say, as you see, this is let's say traditionally we say this is X. Okay. And then this is Y. Okay. Now I want to represent this set of points into using a single dimension. Okay. So let's say these Y points. Okay. This set of Y coordinate we want to represent. So this is 0. Let's say this is 1. This will be 2. And then this will be 3. So this will be 4. And this will be 5. So you have a set of points here. You have 1 point here. You have 1 point here. You have 1 point here. Okay. Now same, because we don't have, we want to represent this set of points into a single dimension. Okay. So this is the representation. What I said, ki if the number of attribute increases, okay, so now you add another attributes, that is X, and we have different values. Okay, as you can see 10, 20, 30, 40. So now you plot this set of 4 points on 2D using this value. Now you present these points. Okay, now first is, this is 2 dimensions. So now it is let's say we have a representation here. So this is 2, this is 3, this is 4, and this is 5. Okay. Now what you do it? So now plot the this set of points. 10. Let's say this is 10 somewhere here. This is 20. This is 30, and this is 40. Even though it is not possible. So now you plot it. 10 2. So 10 2 will be somewhere where? 10 2 will be somewhere very close here. Then 23. 23 will be somewhere here. 34 it will be somewhere here, and 44 will be somewhere here. Okay. Okay. Now you see the variability of, or if you compute the distance, what will you get it? Distance between 2 to 3 is 1, but whenever you compute distance from 10 to 20, you will get 11. So therefore that we learn just that point. So whenever you are increasing the dimension, okay, so therefore what will happen, that each point will be very parsed to each other. Points will be very parsed, it will be located sparsely on the feature space. Now instead of 2 dimension, if you increase one more dimension, okay, so you increase one more dimension, this set of points will be much sparser. So therefore instead of 3 dimension, if you add 1000 dimension, you just imagine the points will be very parsed to each other. It is not only that, it is added another thing, that it will be that each point will be equidistant. That means distance from 10 to 20, even distance from 20 to 30, sorry, these points, and distance from 10 to 40, it will be almost same as almost same. That is, we can say in the feature space they are located in equidistant point. So then what is the problem in this scenario? Problem is that, say, what we want? We want that the similar point should be in a case of the cluster analysis, as we will learn later. The basic idea of the cluster analysis is, our clustering technique is that similar group of point should locate should be grouped in a cluster, or should be grouped. Okay, so but that each point's distance is almost same, so therefore equidistant, so therefore you cannot group them, and therefore you cannot say how many clusters are there, whether is there any structure in the data, or is there any outlier point. It's appeared that each point itself is the outlier, because this periphery, within this periphery there is only one point, and this periphery only there is one point, and so on. So each point will be looked will be a it outlier point. So therefore what we need to do it, we need to reduce the dimension, and this problem is very frequent for application like bioinformatics, document clustering. So number of dimension reaches to above 10,000 or so on. So in that scenario, what you need to do, you need to reduce the dimension. Okay, so I think it is clear. Okay, so now I can move to the our slide here. Yeah, so that is the dimensionality reduction. So avoid the cost of dimensionality, reduce amount of time and memory required by the data mining algorithm. Obviously you are reducing the dimension, so therefore processing time will be, so if you reduce the dimension, processing time will be reduced. Okay, how can you tell, how can we say that? So one example that, and many applications, so what you need to do it, you need to compute the distance from one point to another point. Okay, so now for distance computation, very frequently we use the Euclidean distance. Obviously there are other distance, but for understanding, so we can take any distance measure, let's say Euclidean distance. How do you measure the Euclidean distance? So we compute, so let's say we have 2 points, x1 x1 y1 and x2 y2. Then how do we compute the Euclidean distance? We studied earlier, that is x1 minus x2 square plus y1 minus y2 square, and then you take the square root. Okay, this is so simple. Now you reduce, you do the in original case, suppose you have 1000 dimension, then ideally what you need to do, you'll have the number of terms. Here is 2. So in 1000 dimension, we'll have the number of summation term will be 1000. Okay, and therefore obviously it is very obvious, if you spend 1 unit time for computing, say let's say x1 minus x2 square, so then you need the 1000 dimension, 1000 time unit for computing the some part, and then obviously rest of the thing is like taking a square root, so that will be almost same for the both cases. So my point is that whenever your dimension will be very high, so it will take more time for computing similarity or dissimilarity measures. So therefore, if you reduce the dimension without much what is called reduction in the without much reduction in the data's properties or attributes properties, so we can get the gain in as far as the time concerned. So therefore, this is another purpose to reduce the amount of time and memory required by the data. Now, for your case, for analysis also you need a data, you need the memory. So because instead of instead of 1000 dimension, you can represent the same thing using, say, let's say using 50 dimension or 50 attribute. So therefore memory also will be reduced. So this is the main idea for the dimensionality reduction. So PCA is one technique where dimensionality is reduced. Okay. Now there is something called feature subset selection. So this is another technique is called the for reducing the dimension. So in earlier case, what we are doing it in PCA, we are seeing the where in which direction the variability of the data are there. We are picking those particular dimension. But feature subset selection, say suppose I have 1000 dimension. So out of this 1000 dimension, maybe 60 features are very important and rest are irrelevant or not much important or least important. So therefore, what we can pick instead of 1000 dimension, we analyze with the techniques of 1000 with techniques. Instead of that, what we can do, we can reduce the dimension. We can rather not use the term reduce. We select the subset of features. So instead of 1000 dimension, we select only 60 dimension based on some criteria. So that is something called subset selection, feature subset selection. Please try to distinguish the term used in earlier case and now. So here, in case of subset selection, you have 1000 data, 1000 dimension, and you pick arbitrarily 10 or 20 dimension, and you check whether is there any improvement of results or not. Then you pick another 10 or 20 and so on. So that is something we are not doing any kind of say other kind of analysis. Obviously, we are doing some kind of analysis, but the analysis is happen in case of PCA is different from here. Okay. Irrelevant features. Okay. So one is example is here. Duplicate much or all of the information contained in one or more other attributes. Example is purchase price of the product and the amount of sale tax paid. Let's say one example is age and the date of birth. So it is not required to have in the both cases, right? If you have the data of DOB, then you can obviously you can find the age. Okay, this is like that age is here is redundant features. Okay. So irrelevant features contain no information that is useful for the data mining task at the hand. So one example is student's ID. So as you understand, student ID is often irrelevant to the task of predicting student CGPA. Okay. So therefore you can reduce the that attributes. Okay. And this is very useful for feature selection for the classification techniques. Okay, because in classification technique we have the information about the data instances in which class it belongs. So based on that, what we can do it, we can perform the some kind of analysis. We pick any 10 features and then you see what is the results, because results we can see because it has the what is called is data, it has the level. So you see the result is very bad, then you go on again, you take the some other set of features and then you check out result is improving, then you keep on adding, and after a certain stage you'll find that even though you add the number of features, but that performance of the classifier is not getting improved. So in that case, you stop and you declare these are the set of optimal or number of dimension on which we should work. So this is the way that in feature selection it is done. Again, unfortunately, we won't talk about much on feature selection. Obviously, we will talk about many classification technique. Okay, in this data mining class. So feature creation. So create a new attribute that can capture the important information in a data set much more efficiently than the original attributes. So this is something like that. So suppose you have a set of features. Okay. So instead of using all set of features, you create new set of features and you check out using this set of features, you are getting almost the same results of the earlier using earlier set of features. So then this is another way for feature creation. Okay. So one is feature extraction, extracting the edges from the earlier we talk about subset feature selection. Here is feature extraction. Okay, two are different thing. And feature construction, so dividing mass by volume to get the density. So you have this is very example. So let's say you have the mass and the volume. So and you need to work out with the density. So instead of keeping both the features, say you can keep only the density, or if you have the mass and volume, so you can create a new features that is something called density, and you can use it, okay, for your application. So that is something called feature construction. And then another is example is like you use the Fourier and wavelet analysis that will be taught. Even will not teach. I will not teach this Fourier and wavelet analysis. That will be taught in a what is called is image processing class. Okay. So it appears that I am not teaching anything in this class. Okay. So this is one example. Say on the left side you can see the wave, but if you have a A50, then you will have the very nice feature. You can see on the right side. You can analyze on based on the right side characteristics. Okay. Uh, then is discretization. Discretization is the process of converting a continuous attribute into an ordinal attribute. So let's say in many applications, because the attributes are very continuous, so it is very difficult to have to have a proper analysis. So in many applications I am saying, so what in that case what we can do it, and then in some classification technique like decision tree work on the discrete attribute much better than the continuous attribute. So what you need to do it, you have to discretize. Let's say one example, let's say student's age in a class. So it is a continuous attributes, but what we can do it, we can group. So age between say let's say 18 to 22 one group, and 20 to 26 will be another group, and then you start analyzing the technique. So that is something called discretization. Okay. So this is famous data set is called IRIS data set. So it is a continuous attributes, and it has three classes. So and it has 4 attributes. So all attributes are continuous, but one can and discretize the data and then start analyzing. Okay. So one example is let's say this is a continuous attribute. So you have a petal length and then petal width. So it is found that uh, within, say let's say if you have a petal length is very small, less than 2.5, and then petal width is less than 0.75, so that appears that that data is that type of layer is setosa. Okay. Similarly, we have a different, if it is not too large or not too small, say we have a versicolor flower, or other way it is a virginica. So these are the analysis one can perform if you have a continuous attribute, but corresponding analysis techniques works with analysis technique needs some discretized data, discretized attributes. Okay. This is same thing. Yeah. So when you have a dimension, it is very easy to what is called is distinguish from one object to another object. So let's say if you have a single dimension, all objects here will be placed very close to each other. We cannot analysis, but if you add one more dimension, then we can see it here. Okay. So binaryization is another way for analysis technique, analyzing techniques. So suppose you have a continuous attributes, you convert to the categorical attribute. Let's say eye color. Okay. So as type or another is the black one. So this is the two categories. Okay. So one more example. Let's say if you have a height is a continuous attributes. Okay, you can divide the height into three categorical attributes like low, medium and high. Okay, so and then this is also a ordinal attributes. What we can do it, we need to binarize. If we want to binarize, so low will be low is if this data is low, it will be 1, and if it is not low, then it will be 0. So therefore each value will have the two values, one is 1, another is 0. Similarly high is 1 or 0. Similarly in case of the eye color, say red, whether red is present, if it is present red, red is 1 and otherwise 0. So similarly other black, if it is present 1, otherwise 0. So this is main idea is that you convert the data into from continuous to categorical attribute, even though only categorical attribute can directly, like eye color, can be converted into the in binary attributes. Okay. I think we are very close. Yeah, already 10 o'clock, right? You have class, right?
Yes,
So we have another 3-4 slides. 1, 2, 3. That's all. 3 slides. Okay, I will take only 2 minutes. So attribute transform. Sometimes what we need to do it, we transform the attribute from the one set of values to another set. So one simple example, so let's say x to the power k. Okay. So another example, you take log of x. So that value will totally change. Some analysis we may need to do it, but another two important thing is that normalization. So very commonly, very often we normalize the attribute values. Another is the standardization. What is standardization? So we normalize around the mean of the data. So that is something called standardization. And normalization is also very close to that one, but it is very specific. You can say standardization is a one kind of normalization. I will show with one example. Okay. So here you see. So net primary production is a measure of the plant growth used by the ecosystem scientist. So that is NPP. So if you see the NPP in a Minneapolis, in USA, right? So what you can see, this is the value is ranging from 0 to 155 over the different month. Okay. So, but if you see carefully, that value of NPP is changing for the Minneapolis from 0 to less than 100. Okay. Similarly, if you see NPP, the value is, there is no lower value here. So value is starting from 100 and then below 50, there is no value. So therefore it is very difficult to analyze, because some of the places NPP value started from 0. Some of the places start NPP value, it's not even 0. Therefore what it is done, we should analyze, we should do the normalization on each of the places. So therefore this is a correlation, is a kind of normalization where value ranges between -1 to +1, as you know. Okay. So therefore what we found, we compute the correlation value here, and then everything is normalized, as you can see here. Okay. So now here we got some analysis here that Sao Paulo is negatively correlated with the Minneapolis. Okay, as far as the growth concerned. But same data, if you do the what is called mean zero and unit standard deviation analysis, that is in statistician, we say the standardization will have a different results. That will be the last slide. Okay. Yeah. So here you see, we normalize using Z score. So Z score is nothing but, as I said, the standardization. We subtract from the mean, okay, and then divided by the standard deviation. If you do, we'll have the different plot, okay, and now you find the correlation. After standardization, you do the correlation. And earlier case, we find the correlation after find the correlation. Normalization, it happens within the correlation. So therefore, so especially for Sao Paulo and Minneapolis, now we have the positively correlated. In earlier case, we had the negatively correlated. So many applications, so we only do the correlation. So we don't do the mean standard deviation kind of thing, because it may destroy the structure of the data. But many applications also go for with the what is called is the standardization. Okay. So basically, in the last 3-4 classes, we talk about different pre-processing technique. We talk about finding similarity, dissimilarity. We give the definition of what is object and what is the attributes, and we talk about what is data. So now we'll start about the different techniques applied on the data mining, different data mining techniques applied on the data for giving the inside details of the data. So with that, I wish to stop today's class. I am already late for 5 minutes. Okay, for you, I am fine for, but you will be late. Some guys, I do not see the name, like roll number 3317221 CS. I don't know what is the issue, but you try to resolve the issue. So with this note, I stop today's class.
So can
Here.
you please share the
So
slides?
yeah, before announcement, tomorrow I'll have a class at 10:30. Okay. In the morning, if you don't have any other engagement kind of thing, so then I can take class at 10:30 tomorrow. Okay. So that is obviously a compensatory class. Okay. I'm not taking any extra class.
Sir, excuse me,
Yes.
sir. Sir, we have a class tomorrow for AI, Anup sir. I think around 10 o'clock it is. Compensatory class it is. So maybe it will be overlap the timing.
Okay, then I'll take class from 11. 11 is okay. So I'll talk to Anup sir, and then we'll finalize. Okay.
Okay, okay, sir.
I will let you know. So
Okay,
you visit the course website. So then you will get it. You will get the what is called timings. Okay.
Okay, sir.
Excuse me, sir.
Yes.
Sir, we have a class of software engineering from 11 tomorrow.
Who is the faculty?
Judhishthir Mohapatra, sir.
Okay. So evening, do you have any class? Anyone is having class? 4 to 5.
No, not from my side, sir.
So then I am shifting the class from 4 to 5. Okay.
Okay, sir.
Okay.
No, sir, we have a class, software engineering. We have a project management class.
Hmm?
Sir, we have a class.
At what time?
4 to 5, 4:20 to 5:15. We have a class schedule.
Who is taking this class?
Durga, sir.
Is it a compensatory class or it is extra class?
No, sir. It is a compulsory class, means it is according to the timetable. So it
Saturday is
won't be
timetable you have.
Saturday is a free day. Most of the professors have shifted their lectures to Saturday, but I don't know what timing they will give.
Saturday you have a regular class or what?
No, sir. Saturday we don't have a regular class. We have a regular class till Friday only. But some of the professor have shifted some class to this weekend only. But they'll convey on the same day, on Saturday. So that's the case. Friday evening we have a class. We software engineering batch have a class Friday evening. 4
So
to
Friday is
5
a
there is.
holiday. Friday is a holiday, right?
Okay. So Friday is
Tomorrow is
tomorrow
the
only.
holiday.
Okay.
So if I take a class, I will take on Saturday only, not on holiday. Even though Saturday is a holiday.
Okay, sir.
So how many students you have a project management class? So only software engineering student.
Yes, sir.
Sir, excuse me, we are getting late for our AI class. Can we leave?
Yes, you can leave. Okay.
Okay, sir. Thank you.
Excuse me, sir. Hello.